In this video, we are going to discuss about problems on transient analysis with the help of Laplace transform. So, you can see any type of problem can be solved using Laplace transform, and have also in a simple way how to first I have solved using the problem using Laplace transform, and after that we in a regular way I have solved the problem without using the Laplace transform, and I have verified the answer. Okay, the question is here the 10 volt is connected to 3 ohm resistors and 2 ohm resistor, and you have two switch, one is 1 and 2, and they have asked to find the voltage across the Vc of t. That is a voltage across the capacitance. And the question is it has been in the position for one for a long time, and it has to be at t is equal to 0 plus it goes to the position 2. Okay, you can see you have a current source and voltage source and resistor and capacitor. So it is since you have only a resistor and capacitor, it is nothing but a first order circuit. So if I have a resistor, capacitor and inductor, it is called as a it is not a first order circuit. Okay, so first we have to be in order to find t is equal. So at t is equal to 0 minus and t is equal to 0 plus. So both are to find t is equal because the voltage across the capacitance will not change. Therefore, the Vc of 0 and 0 plus value are same. Okay. So first, before that, we need to find the value of Vc of 0 minus. So to find the value of Vc of 0 minus, the switch has to be connected to the position 1. So if this is connected to the position 1 means what I should do, the 10 volt source is connected to the 1 resistor, and the value is 3 and 2 ohm resistor, right? And you have a capacitor, right? So across the capacitance only we need to find the value of Vc of 0 points, right? So if I want to find the voltage across this capacitance, you have to open circuit this, right? The capacitance has to be open circuited. And if I want to find the voltage across 2 ohm, okay, so 2 ohm means you can apply the voltage divider rule. The 10 volt is divided across 3 and 2 ohms. So therefore the formula of Vc of 0 minus, right, that is Vc of 0 plus, right, that is equal to 10 into 2 divided by 2 plus 3, right? So that is nothing but 20 divided by 5, right? So what is 20 divided by 5? 20 divided by 5 is 4 volt. So the next step is we need to find t of 0 plus. So for that one you have to move the switch to 0 2, right? So if I move to 0 2, in addition to the capacitor, I have to connect the initial voltage, that is 4. So I have to write it as 4 by S, right? So in the capacitance value, you have to write it as 1 divided by SC. C value is 0.1, so it is written as 1 divided by 0.1 into S. So likewise, the current source phi should be written as 5 by S. Okay, the resistance value should be as same. So that is 4, 2, 1, 2. Okay, so the current flowing through this one is 5 by S, and this one I can take it as I1. So this is nothing but 5 by s minus I1. Okay, so for the first loop, that is that next loop, I can write the equation in terms of so I can write it as 4I1 plus 4 by s. So 4 by s, it is a voltage, right? So I can write it as 4 by s. 1 divided by s 0.1 into I1, because it should be treated as it's more like this is minus, because the current direction is opposite, right? Minus 2 into 5 by s minus I1 equal to 0. So if I solve 4I1 plus 4 by s plus 10 divided by s into I1 minus 10 by s plus 2I1. Okay, that is equal to 0. So if I again simplify this equation, 6I1 minus 6 by s plus 10 by s I1 plus equal to 0. Okay, so I1 you take it common, so 6 plus 10 by s is equal to 6s. So I1 is equal to 6 by s divided by 6s plus 10 divided by s. So s's get cancelled out. So you can write it as and 6 you divide it by 2, you will get 3s plus s, 3 divided by 3s plus 5. Okay. So we can write the voltage across the capacitance. There is Vc of s. That is equal to, so Vc of s is equal to 4 by s plus 1 divided by s 0.1 I1. Okay, so I1 you take this value and you substitute this one. So if I substitute, I will get 4 by s plus 10 by s into 3 divided by 3s plus 5. Okay. So I'm just substituting the value of I1. Okay. So next you can apply the partial fraction method in order to find the value of you know that I can write you can take the 3 as common. Okay, so if you take 3 as common, the 3 will get cancelled out and you will get s plus 5 by 3. Okay, so for that one you can apply the partial fractions. So 4 by s plus 3 you can take it common. So I can write it as for 10s into s plus 5 by 3, I can write it as a divided by s plus b divided by s plus 5 by 3. So take LCM, a into s plus 5 by 3 plus b into s, that is equal to 10. Okay, so if s is equal to 0, I will get a is equal to 5 by 3 of a is equal to 10. So a is equal to 30 divided by 5, that is 3. 30 divided by 5, that is 6. So if I substitute s is equal to minus 5 by 3, I will get minus 5 by 3 of b is equal to 10. So on solving, b value is equal to minus 6. So I substitute in the above equation, that is 6 by s minus 6 by s plus 5 by 3. Okay, this 10 divided by s is from the above equation. So 4 by s plus 6 plus s minus 6 divided by s plus 5 by 3. So I can write this Vc of s is Vc of s, right? It is not in time domain. So Vc of s is equal to 10 divided by s, right? I can write it as 10 divided by s. Okay. uh, so the 10 divided by s I can if I take it in time domain, I can write it as 10 minus 6 into e power minus 5 divided by 3 t, because s plus 5 by 3 in the denominator, I can write it as e power minus 5 by 3 of t. So this equation only we have to verify. So I'm telling you the short way how to do this problem in a simple way without adding this initial voltage and all. Okay, so let us do the problem. For that one, I'm going to take the node consider the switches in the position 2. Okay, so if the switches in the position 2, you will get this 3 resistor that 5 amps, and you have a capacitor, right? That is 0.1 farad, and a resistance value. These are the resistance value. So first you need to find the value of R equivalent and C equivalent value. So now to find the value of R equivalent, you have to find across the capacitor, right? So if I find across the capacitance, means you have to open circuit that capacitance, and in order to find the R equivalent, the current source should be open circuit. So if the current source is open circuited, then R equivalent is 6 and C equivalent is 0.1 farad. Okay. So we know that Vc of t is equal to Vc of infinity plus Vc of 0 minus Vc of infinity into e power minus t divided by tau, where tau is equal to Rc, and Rc is nothing but R equivalent C equivalent, or I can write it as L by R if I have only resistance and inductors. So you substitute the value of R and C, you will get tau is equal to 3 by 5. Okay, now I'm going to substitute this value. So we have already found out the value of Vc of 0, right? There is 0 plus and 0 minus. So I'm going to substitute in this equation. So that is 4, right? And I'm going to substitute the value of tau. What is tau? Tau is 3 by 5. Okay, so we substitute the value. Next, to find the value of Vc of infinity, right? So to find the value of t of infinity, so the switch is on the position of 2, right? So you have to open circuit the voltage across the capacitance, right? So to find the value of Vc of infinity, so you just open circuit the capacitor. Okay. Then I connect these 3 resistance 4, 2 and 2 and 5 amps, right? So the current will flow only when the circuit is closed circuit. So here you can see for the 4 resistor, there is no current flow. So I can write the entire current will flow only through the 2 ohm resistors. So the voltage across this 2 ohm is 10 volt. That is nothing but Vc of infinity. Okay, so you substitute in this formula 10 plus 4 minus 10, that is minus 6 e power minus 5 divided by 3 into t. So on solving, we get the answer as 10 minus 6 e power minus 5 divided by 3 of t. That is nothing but Vc of t. So you can verify the answer with the help of the Laplace transform. So that is Vc of t here. Okay, Vc of t is equal to 10 minus 6 e power minus 5 by 3 of t. So this is how you have to solve the problem. So I hope this video is useful.